in time, we promise. So my name is John Russell. This is Senthil Bala. I'm the solution manager at Dell for our Microsoft desktop virtualization solutions. Senthil's our solution development manager, kind of our lead engineer for VDI. Hopefully we have a lot of exciting stuff to show for you here today. We're going to talk about all the interesting things that are going on with Dell and Microsoft VDI. We have a demo, so it's not all slides. I promise not to sit here and just show you a whole bunch of slides. We'll keep it to hopefully a show minimum. That's our goal. So if you have a coffee, sit back, relax, whatever makes your morning here at 8:30 a.m. in the wonderful city of New Orleans a little more enjoyable. So we want to go through a couple things. One, I want to talk about why Dell's in this business. So what is Dell doing with VDI? What is our strategy around it? And how do we go about building the solutions that Senthil is going to talk about? So we've been doing this for actually a number of years now. We're really focused on taking all the different pieces. We live in Dell Desktop Virtualization Solutions Group. So we're focused on taking all of the different various pieces from the Dell portfolio, driving new requirements into those groups, putting them together into what we think are some of the best VDI desktop virtualization solutions in the market. Not just VDI, other things as well. I'll use the term VDI interchangeably for all the different ways to virtualize your desktop and your apps and your OS. But we've spent a number of years taking the best pieces of storage, networking, server, software, client, and putting those together in what you're going to see, we hope, are some of the best desktop virtualization solutions in the marketplace. We'll talk about the work that we do that goes behind it. So we put tens of thousands of hours. Senthil can tell you at a lot of late nights to meet the launch deadlines we have for a lot of our platforms. We have them all in the booth, so we certainly invite you to come by, take a look in the booth. We can give you in-depth demos, spend more time with you, give you all the information that you're looking for. So if you don't take anything away from this at all, number one, come by the booth. We'll give you any information that you'd like, some of the printouts for our reference architectures and our solutions. We're happy to talk to you in the booth. I actually like to use this slide because it's a little bit older. The information is kind of interesting to take a look back and say, what did we think about desktop virtualization a year ago? And one of my favorites was about 40% of the research survey showed us that non-standard devices had to be supported for executives. So I kind of imagine how many people in here are supporting non-standard devices for executives. That could be iPads, their home PC, their phone, whatever. It's probably a lot higher than 40% these days, or more of them have become standard devices. And probably one of the ones that was also interesting was the number of growth in these devices. So outside of the PC notebook, the standard thing that we would deploy, they were predicting, well, you're going to see 66% growth in these new devices. We're going to support more and more devices. That actually turned out, the last research we did showed 48% just in smartphones alone. So the number of devices that people had to support just for smartphones grew 48%. It's predicted to grow even more and more. So we have a lot of tools behind it that we'll talk about for managing these devices, fitting them into the environment. But how do you integrate all these different software applications, operating systems, platforms, and deliver them seamlessly to your end users? And that's kind of what we're going to talk about today. So we see a lot of challenges, users being more mobile. Not all users, but the majority expect some larger notion of mobility. So whether that's from their phone, from the coffee shop, from their house, how do we enable them to work from more places? We see a more global workforce in a lot of cases, so outsourcing, different remote branch offices, small offices. How do we support all these users and all these applications securely and still give them a good experience with all these new devices? And certainly one of those ways to do that is desktop virtualization that we'll talk about. We've been doing this for quite some time. What we found with desktop virtualization is it's a really cool technology. I mean, how many in the room are actually looking at desktop virtualization right now in their environments? Good, because the desktop virtualization session makes a lot of sense. How many have deployed desktop virtualization to some extent? Well, that's pretty much what we're seeing. So a lot of you are looking at it. Some of you deployed. A lot of you are probably looking at expanding your environments. How are we going to support more and more of these desktops and do it easily and quickly and manage it? But what we see behind deployments traditionally is, while it's a really cool technology, if there isn't a driver behind it or a reason to go do it outside of it looks kind of cool, the projects generally don't succeed. So when we talk about why we build what we build, a lot of them tie back to these drivers. How do you make it easier to enable BYOD? Right? How do you make it so you can bring non-standard devices, in some cases non-Windows, non-Microsoft devices, into your environment easily and manage them and support them? Migration, right? How do you ease a migration from a bunch of 3 or 4-year-old desktops, in some cases older, running XP? Anybody still running XP out there? Yeah, see, here's a bunch. With their applications that can't move for whatever reason, how do you ease that migration for both the end users and yourself over to a new portfolio and a platform? We'll talk about some of our solutions in that space and how desktop virtualization plays there as well. But each one of our customers who've succeeded with VDI generally have a driver behind the project. And every project, every user group, every individual project may have a different driver, but each time the projects are just a cool technology, they generally don't succeed. They have to have one of these business drivers or end-use improvement behind the actual project. So I'll talk a little bit about why we do what we do and what drives our decision making. So when Sentinel talks about the solutions that we built, and we actually share everything that we do. So all the work that we go, the research, the study, we don't hide that. We actually will share our sizing, our information, our guidance. We provide how we built it, how we set it up. We share that with customers. Whether they buy from Dell, whether they buy from a Dell reseller or not, we openly share that information to help any customer who's interested take a look at what we're doing in this space. But these are the things that drive our decision making in VDI. So you see improving end user productivity. So delivering any application to any user on any device. Big statement, but what is Dell actually doing in this space? So I'll give you a proof point. I mean, has anybody heard of Pocket Cloud before? I see almost none. I see one or two. So Pocket Cloud came from the Dell Wise team to continue to develop it. Pocket Cloud enables VDI on pretty much any device, right? So iOS, Android, where they don't have a native RDP client. How can I get into my VDI environment a little bit more securely? Well, we have Pocket Cloud in that space to improve end user productivity. It actually makes the experience, hopefully those of you who tried it, if you saw a few hands go up, Pocket Cloud makes the experience a little bit easier. It has a wheel, you can right-click, you can do things. You can imagine giving users full VDI with, on a smartphone. Anyone tried to use a full desktop, Windows 7 on a smartphone? Not exactly the greatest experience on the planet. Pocket Cloud can help that, right? So the wheel allows you to right-click, zoom, pinch, do a lot of things that you couldn't do just with a native or a standard RDP client. So we had some IP around that. Securing the data. So we're focused on one of the biggest drivers of VDI is security. So how do we secure that data? How do we secure remote access with things like SonicWall, VPN clients, into your thin clients, things like that? How do you make it more secure or most secure? It's one of the biggest drivers for our customers. Maximizing that spend. So when we go through the solutions, they all have a different cost. But our goal is to make it easy to deploy and one of the lowest cost solutions to deploy in the marketplace. And we talk about, we can actually give you a cost for any solution that you'd like. But when Sentinel talks about the solution stack, you'll see our sizing is based on real world loads. So we're not going out and giving marketing statements for it's $100 a seat for a user who doesn't do anything, and you can pile 1,000 on a server. We actually use real-life workloads that you can translate to your environment. So when we say you can get 120 users on an R720, that's what you get. We tell you exactly the IOPS, the CPU, the memory, the hard drive space that goes behind those pieces of information. So we're not making marketing statements around cost per seat just to get you interested, and then when you deploy it, you find out it costs 10 times as much. So we keep it very focused on realistic workloads. And then simplified management. So how do you make it easier to deploy this, easier to manage it? And Sentinel will talk about some of those pieces today from both the endpoint, so perhaps a Dell Wise client, a repurposed desktop, things like that, all the way back to the back end with plugins for your servers, your storage, your networking. And then we'll also talk about how Active System plays into that as well. These drive our decision making. So you can build a VDI stack out of anything. You'll buy the bits, pieces, and parts from anywhere. But we try to focus on putting them together to achieve these goals. That's what drives kind of our business. So what are our solutions? What do we have in this marketplace? So the way I put it, we really have 4 core offerings, and they'll branch out from here, and it'll make a little bit more sense. But we have a simplified appliance. So for customers who are saying, I don't care how it goes together, I just want to plug this thing in, launch it, and go. We have a growing family of simplified appliances today based on VDI in a box from Citrix. Not really our focus here, but we do have simplified appliances. We continue to offer other solutions in that space to make it easy to deploy. So how can I, instead of building an architecture, a huge thing, I just want to plug boxes in and make them easy to deploy. So we have our simplified appliance line. Then we have our enterprise infrastructure, so DVS Enterprise, stacks that we've built around reference architectures, and I'll talk about them for Microsoft, VMware, Citrix, and vWorkspace, which we announced here at the show as well. And then we can also do it as a service. So for customers that say, I really don't want anything to do with this. I want to try it. I want to put 30 users on this, a remote office. I don't want to worry about it. I just want to cut someone a check, and 30, 40, 50 bucks a month, and not have to worry about anything. We offer DVS Simplified as a service. We'll provide you a desktop or through our reseller channel, provide you a desktop hosted by us, updated by us. You just provide a couple pieces of information that ties to your Active Directory, and we'll deliver desktops to you in under a week, up and running, virtual desktops. And then we can do it a little bit more custom. So if you have specific things you need in your environment, different security requirements, things that you'd like to see, we can deliver it as a custom, or we'll host it as well. One thing that we've learned through our deployments, so we have a methodology that we share. We do it, our partners do it, our certified resellers generally walk through it, is how do you go from I'm interested in VDI to, there's like a train going behind the room right now. Not sure what that was. What our customers have told us is that we've built a process around VDI, so we've seen a lot of failed projects, and Sentinel will give some fantastic examples of wonderful failed VDI projects. antivirus in VDI without testing it out, for example. Architectures crashing when virus scans start running. Those are the types of things that we built a process to help understand and walk customers through. So kind of the first thing that we do is feasibility. So I'm the first one to stand up here and say, VDI is not right for everyone. Right? There may be some other virtualization technology. You may just stick with desktops or notebooks for a specific user group, but desktop virtualization isn't right for every single customer. It's right for certain scenarios with certain business drivers and requirements. But we actually walked up to customers and said, I want to buy VDI. And we said, it's not right for you. You know, the first conversation was, well, tell us a little about your network and your applications and your users. And our response was, this isn't right for you. You shouldn't do this. And some of them have listened, and some of them have done it, and they failed, and they came back and they bought desktops. So we try to share that information that we've learned over the years as part of our process. And then discovery workshop. So we walk our customers through understanding their users a little bit better, the applications they want to run, what type of workload they're expecting. And then probably the most important piece is the blueprint. So in the rush to get to VDI and the interest in VDI, a lot of customers will skip the step around kind of the planning stages. So I'm not saying anybody in here would do that. But part of the blueprint assessment is actually taking software, running it on your users' endpoints to see what they're actually doing. So if we make an estimate, well, I think most people are running Office, and they're using, I'll put them on one core CPU with 512 memory, and they'll be fine. With 10 gigs of storage, they'll be fine. Without that tool to run in their current environment, it's really hard to understand what workload they're going to bring into VDI, and a lot of customers have been surprised. So they gave them way too little horsepower, or they way overspec'd and way overspent on their architecture. So that's important to understand using those tools to actually run it on the user, see what they're doing. So when you give them this new environment, they know exactly what kind of experience they're going to get. And that goes down to the design and proposal. So either us or our reseller partners or certified partners can develop a proposal that's specific for you. Maybe it's as a service, maybe it's managed. We build those out. And of course, implementation services. And we can take the keys and drive it, or we can hand the keys over to you when it's done. Obviously, we like to talk about endpoints as well. We're Dell. We have some fantastic endpoints. So with VDI, the choice of endpoints is very, very broad. We think we have some fantastic, obviously, desktops, precision workstations that can be used as clients in some scenarios. Some fantastic laptops, XPS 12, Latitude tablets, if you haven't seen them. We think they're pretty nice. They're not $99 like here at the show, so there's not a giant line of people around our booth waiting for our Latitude tablets, but that's a Microsoft thing. So, and then mobile devices, and of course, the Dell Wyzen client. So industry leader in cloud client computing clients. Fantastic experience. We have some of these at the booth, running the latest operating system and updates around RDP8, Remote FX certified, deliver a fantastic experience on the endpoint. So outside of those solution stacks, we spent some time, what we're announcing here at the show today, or actually it was Monday that we announced this, is how can you go deploy this? So some key scenarios, customers have come to us and said, how do I deploy this? How do you make it easy for me to deploy this? And the first one up at the top is our active infrastructure, where we will deliver to you a rack, pre-built, pre-configured, preloaded, pre-cabled, that you can simply one plug into your environment, get up and running with VDI as soon as it gets there. Usually about 5 to 7 days. So we offer active infrastructure, which are predefined, preloaded stacks that are built ready to plug in. So instead of taking all the pieces, putting them all together, trying to figure it out, we'll drop that on your site. Ready to go. We'll give you the sizing for what we expect it will do. You can compare that with your requirements. We can deliver that in about a week, right, to your site. The other option is we can customize it. We understand a lot of customers have their own storage or their own networking. They may want to bring a certain type of server or WAN accelerator. Well, we'll customize our solution. So everything we build, as Senthil goes through it, it's translatable to other vendors as well. So if you use a different type of storage, we can tell you the IOPS. If you use a different type of networking, we can tell you the port configuration, the speed requirements, all those types of things you need to integrate that into our stacks. And then we can do fully custom. So if you have some really crazy things, really weird sites with really weird equipment, we've done some interesting things with customers as well. So some of the deployment options for VDI. So we can go from here's everything, here's a key, you're up and running, to we'll customize it exactly for your environment. I did want to spend just a little bit of time talking about active infrastructure. So our active systems launch. What you'll see with active systems, these pre-built, predefined, pre-configured solutions, very intuitive. So ASM, the software, actually helps you deploy faster, so automation. So what we're trying to do on these stacks, instead of just giving you a bare piece of metal and saying, good luck, use your standard tools, we're trying to give you a way to make it faster to deployment. So ASM software actually automates a lot of that deployment, and the VM and the configuration. Senthil can talk about that. And they're purpose-built for these solution stacks. So when you see them, they show up, we'll tell you exactly what type of workload they'll deliver. And then we think they're pretty flexible. So when you see the compute, actually what they can deliver for the specific scenario, whether it's also available for SQL Server, other things as well. But when you see it for VDI, you can see that we can deliver, hopefully, what we believe is more compute per rack. OK, so with that, I'll stop. The marketing pitch is over. Thank you for listening. So we're going to get into the technical piece with Sentinel. It's going to go why we build our stacks, how we build our stacks, and it's actually going to give you a demo of some of the technology and why making these choices, making the wrong choice can be a big mistake, and then why the good choice will actually deliver a great experience to your end users. Sentinel?
Thank you, John. My name is Senthil Baladhandayan. I work as a solution development manager along with John. Today I'm going to walk you through how we built our Dell Microsoft VDI architecture using Windows Server 2012 as well as Dell hardware. In the agenda, we'll cover about what are our design goals, why we designed the architecture, our solution models, different software and solution architecture. We'll walk you what are the real-world workloads we used, including graphics workload and link workload. We'll tell you what are the performance results we got, and finally, we end up with the demo. Stay for the demo. Even if you walk out in the middle, come back for the demo. So what is our design goal? We had 4 design goals in mind when we designed our solution. Today, most of the customers deploying VDI, most of the VDI pilots or even the production environments fail because VDI is too complex to deploy and manage. Most of the how many people have tried VDI and said, it's not for me over here, or at least failed in some kind of initial POC phases. So we want to make sure when we choose a solution, we want to make sure it's easy to deploy and easy to manage. And I'll walk through what are the tools we use to do that. The second one is we want to make sure the solution is highly customizable and flexible. This is something we hear from a lot of customers saying, we have our own storage networks, or we have our own switches, Cisco switches, or EMC storage, or NetApp, or even Dell old hardware, or even thin clients, or when they want to repurpose their own PCs, they want to say, I don't want to buy thin clients now, I want to just repurpose our PCs. How can I accommodate it? So what we do in the flexibility model is we give them choice. Right? We say, if you want to use your own storage, we'll give them, these are the IOPS you need to calculate before you deploy the VDI solution. Similarly, if you want to use your PCs, we say these are the criteria. You need to have this many megahertz and memory to render the remote FX-based systems. And third one is we want to make sure the solution is highly scalable. From POC, whether you're deploying a POC or a production environment, we want to know that you can scale from 50 users to 500 users to 1,000 users without increase in cost or the manageability. Right? If you're talking about $100 per user, when you deploy 50, you want to make sure that number stays when you deploy 1,000 users, 2,000 users. How do we do that? And finally, we want to make sure the solution is easily affordable. Most of the people think that VDI is complex, high cost. Today, we are selling Microsoft Pro for $399, right? How can we meet that cost by deploying VDI, right? So we want to make sure we want to be cost effective, but also effective. We'll see how we build that. So what are our different solution models? Right from the bottom is our flexibility model I talked about. Flexibility in terms of hardware choices, software choices, as well as data center components. Hardware choices, we can give you guidance on storage, network, server configuration. Even if you're deploying on a HP or a Cisco service, we can tell you how many cores, how many memory, depending upon your workload. GPUs. Software choices, whether you're using Windows Server 2012 or some of the other technologies like Citrix and other stuff, we can give you guidance. Clients, whether you're using a mobile client, if you're dialing in from a mobile or a tablet PC, how does your experience look like versus when you're using a PC, how the experience look like, we can give you guidance. The next level in the portfolio is the most optimized solution. Why we call this as optimized is today, if you go to Dell websites, we sell hardware, right? We sell server, storage, network, thin clients, PCs, tablets, plethora of products. As a customer, how do you know that from all those choices, which one is best for you? We have a lot of portfolio products. What we do in the second category is we pick the best out of our server portfolio, networking, storage portfolio, thin clients and fat clients, put a solution together, test it, validate it, publish reference design, give sizing guidance so that you don't need to do the guesswork when you go to Dell.com and say, I want that server or I want this server. You can confidently choose by using our reference design. You can say, I want an R720 server with this many cores and this many memory. Or if you're deploying GPU, you can say, these are the GPU desktops and servers you want. And finally, the active infrastructure pre-integrated systems, as John talked about, this is a pre-configured, pre-designed bundle that's pre-racked at our factory, delivered to you with white glove services to integrate with your production environment. They'll come and walk and set it up, make sure it works, and walk away in 2 weeks. It's a pre-defined bundle. If you want 50 users, they'll give it to you. If you want 200 users, we have a pre-configured bundle for you. So what are the solution parts? So our solution contains 3 components mainly. Obviously, the hardware, the server, storage, networking, and thin clients. The second one is the software, we use Windows Server 2012 with the RDS features for our VDI technology. We also have a product called Dell vWorkspace 8.0, which we acquired through Quest acquisitions, which can also deploy VDI and RDS Edge. And along with this, we couple our services, blueprint assessment and app packaging and migration. Whether you're migrating from XP to Windows 7, or you're migrating your apps from a physical world to virtual world, we can bundle these services with any of the offerings. With the solution pods, we have three kinds of pods. First one is a 10-user trial kit. We call this a trial kit because it's a small server you can buy to test out VDI. You don't need to buy an expensive server hardware. If you just want to have a taste of VDI, you can buy this T110, costs very minimal. You can deploy Windows Server 2012 with RDS, and you can test up to 10 users. You can test all the features of RDS, RDSH, RDVH, pooled VMs, persistent VMs, everything in this box. The second one is we call it as a Dell cluster in a box. It was announced yesterday. Come to the Dell booth. This is a if you don't want to configure complex hardware like storage and networks, you want everything contained in a single box, this is an excellent box for you. It has 4 nodes, 4 compute nodes with 25 disks, everything contained in a single chassis. Advantages, you don't need an external storage, you don't need an external switch. Only external switch you need is if you want to go outside. Everything is contained. It's a beautiful box. We announced it yesterday. It'll come out soon. And we think we can support, we have validated up to 300 users, but we think we can support up to 500 users in this box. Self-contained, highly available, clustered. We use Windows Server 2012 clustering, and highly available out of the box. And finally, your data center components, active infrastructure, whether you want to go with your server, storage, and networks, we can give reference design based on the server storage network on this hardware. All of these are coupled with our thin clients, starting from T10, which is our thin OS-based Linux clients, all the way to Westside-based to the Pocket Cloud if you're using Android or iOS. So we talked about a lot about solution parts. Let me walk you through briefly about RDS software architecture. If you're deploying VDI using Windows Server 2012, there are 6 roles you need to configure in order to successfully configure a VDI environment. First one is the connection broker. The connection broker allows you to connect your end user resources, end user client to the resources they have access to. So brokering the connections between the client and the resources they have access to in the server, whether it's a desktop or a terminal server-based apps. RD Web Access gives a UI view of all the resources a user has access to. RD Gateway securely allows you to access your corporate resources from outside. Licensing server keeps track of your RDS CALs. RD Virtualization Host is the role you configure to deploy pooled desktops or persistent desktops. And finally, RD Session Host is the one used to deploy good old terminal server-based apps or desktops. Once you configure this role, next one you want to configure is the collections. Microsoft supports 3 types of collections as a part of RDS. First one is the RDS session-based collections, which is a good old terminal services. And in the VDI category, they support pooled and personal VMs. There are advantages and disadvantages of this model, completely up to you what you want to deploy. Session hosts are most cost-effective. You can put a lot of users on a single box because everybody's sharing the resources. But you have issues like app compatibility. Some apps may not be compatible with Windows Server 2012. They have limited personalization. Next category is when you come to pooled VMs, everyone gets a single VM. Advantages, everyone has a single VM. You don't have app compatibility issues, but now your cost increases because they are consuming more resources. And finally, personal VMs. This is the best. Everybody gets their own desktop, personal desktop, but the cost goes high because now the storage costs are high. And they get full personalization, no app compatibility issues. So let's see how all this fits together. In a LAN scenario, thanks to Ara for learning this slide, but this is a Microsoft slide I borrowed, but the concept is the same. Users on a LAN connect to the RD web, user logs in, RD web contacts the connection broker, gives the list of resources user has access to. User clicks the resource, either a desktop or a collection, establish the connection to the broker directly through RDP. RDP connection broker finds out what's the best resources assigned to the user. And finally, a direct connection is made from the user to one of the resources you have access on the data center, either a desktop or an app. In a WAN scenario, same thing happens. User contacts the RD web. RD Web contacts the connection broker. Connection broker gives a list of published apps and collections. User clicks on a published app or a collection. Now a secure tunnel is made between the user and the RD connection broker through RD gateway for him to successfully connect from the external network. The connection broker gives the list of resources user has access to. And finally, a secure tunnel is built between the user and the list of resources he has access to through RD gateway. So there's no security gaps. So we talked about RDS solution architecture. So let's walk through what is our solution. How did we build our solution using the hardware, and how did we size it? Before I jump into too much of the hardware architecture, if you're not familiar with Dell hardware, I want you to just look at this slide. I'll walk you through each one of those. First one is our fast 10 line of switches. It's a 1 GB switch. We used it for routing LAN and iSCSI traffic. Second one is our rack server we used in our architecture. R720 comes with up to 16 disks, and I believe 760 GB of memory and dual socket, 12 cores. Third one is our Ecologic line of product, Dell Ecologic PS4100. We use this for storing the user data as well as the management VMs. Fourth one is the first one you see is the T110 server, the mini 10 user trial kit. And the new one, the Vertex, we announced yesterday. It is the cluster in a box environment. You can support 4 nodes with 25 disks. And finally, our plethora of thin clients from ThinOS, Dell Wise T10 and D10D, we announced new. And the Westside-based remote FX certified clients, T90D8 and Z90D8. So what is our solution architecture? So when we architected this solution, we have one design choice, right? We want to make sure the solution is linearly scalable, and also cost is kept to a manageable level. We call our architecture local tier for one reason. All of the VM sessions run on the server. So when you configure 100 desktops, all of the VMs run local to the server. So your CPU, memory on the disk, all of them are running on the server. Only thing that gets stored on the SAN device is your management VMs, as well as your tier 2 data, such as user data or profile data. And all the VMs are running on the server. So we call this a local tier 1 architecture because everything is local to the server. The advantage is, if you want to add another 100 users, all you need to buy is hook up another server, and you can increase the scale without even adding more cost to your deployment. So linear scalability is one good advantage. You have good, everything contained, so predictable scalability is also another advantage you get. So in the future slides, you'll see this architecture getting repeated in most of the slides, and I'll walk you through the design choices. So the 10 user pilot. So this is a T110 server with the 1 socket, 1 CPU. We have 16 GB of memory, 4 hard drives with 7.2 RPM. You see the management VMs and user data are configured in the hard disks. And all the roles we talked about, the connection broker, licensing server, virtualization host, all the roles are configured on the single server, along with the file server to access your user profiles. We tested this with 10 desktops. We used a workload from Login VSI, light workload. Frank is sitting over here. He can tell a lot about Login VSI. He has cards to give to you at the end of the session. But we are able to get 10 office productivity workloads on this box. Again, you can test it out, see how the VDI is. You can get a feel for VDI if you're not familiar with the VDI. Switch is optional. If you want, if you don't have a 1 gig switch, you can buy our Fast 10 S55, or you can use your own switches if you have one. The next architecture is based on the rack servers. So I want to concentrate on the 4 colors. First one is kind of yellow. That's the switches. Second one is our compute hardware. Third one is the management, and fourth one is the 4100E. So let's start from the bottom. The blue color, 4100E is our tier 2 ecologic SAN. The things we stored in this are 3 things. The management VMs that needs to be configured, the profile disk, and the user data. The my documents and all the steps are stored over here. The user data is your user shares. Management VM has like 500 GB of, we allocated 500 GB. User data, 2 terabytes. You can go more. This can hold up to 12 terabytes. User profiles, 20 GB. Management server is running connection broker, licensing server, RD web access, and gateway, along with the file servers mapped to the user data. It has 32 GB of memory, 2 hard drives connected to the PS4100. All the things are booting from the SAN. The compute host has dual socket, 96 GB memory if you're configuring session host, because it doesn't require a lot of resources to run a session host environment. Or if you want to deploy VDI, you can go with the 192 GB memory. We have 12 into 15K hard drives, 2 CPUs. And in the same configuration, we have validated AMD cards with 3 GPUs or NVIDIA cards with 2 GPUs. I'll walk you through the graphics architecture in the next few slides. And finally, our fast 10 switches we use to route LAN and iSCSI traffic between the architecture. So in the red color, you see we were able to get 260 RD session host in this server configuration, 260 based on long MBS Lite workload running Office application. The same configuration, we are able to get 150 pooled Win7 SP1 desktops. We're able to get 230 pooled Win8, exact nothing changed in the hardware, but Win8 is much optimal to run in a virtualized environment. So if you're planning to deploy Win8, this is something you want to look at. Same hardware, the density is 50% increase with Win8 deployments. And if you're planning to deploy GPUs, we were able to get roughly 30 to 32 per GPU, and we were able to get 100 GPU Win8 desktops. So as you scale from pilot environment to production, you want to make sure you always configure the HA. The way we architect our HA is 5 easy steps. First one is make sure a hardware tier is highly configurable, right? Highly available. That means you have sufficient management nodes, 2 management nodes, your switches are stacked, you have multi-path connection to your storage, everything is redundant. Make sure a hardware tier is firstly fully protected, redundant. Second one you want to configure is create a cluster storage volume on the PS4100. Cluster your management nodes using Hyper-V failover cluster. Configure the SQL. We need SQL in this configuration because connection broker requires SQL. And in order to protect the SQL, we are configuring SQL in a SQL mirror configuration. And finally, configure the connection broker in a highly available environment. You may ask why we didn't configure RD web access and gateway in a dual role. You can do that if you want. It's just simplicity of design. We found out that when we plug the power of one of the devices, it seamlessly migrates in a matter of seconds to the other device. You can put a load balancer and you can make it redundant too. Same with the file server. You can have scale-out file server if you want to make sure the file server is redundant. You can do that too if you want a fully redundant configuration. For the compute, we say in the pool desktop environment, we say you can have 1 extra host. So if you lose a connection for one of the hosts, it can automatically fail over to the second host. Very simple design. All of these things along with the connections, how we configured our architecture in our reference architecture. So please don't go download it and see how we designed it, all the wiring connections, all the roles, how we configured. Every step is documented in our reference architecture. So graphics, this is a very important topic, right? I mean, graphics is new, very interesting, right? A lot of vendors are coming up, AMD and NVIDIA are coming up with their graphics cards. So what we did was we validated cards from NVIDIA, the grid cards K1 and K2, and we validated the ATI cards from AMD. Let's see the specification of these cards. NVIDIA Grid K1 and AMD Aspire Pro, if you're deploying like a medium level graphics, not very intensive graphics, not like a designer workload, these are pretty good, what we found out. The NVIDIA Grid one it's a new design from NVIDIA. They have 4 GPUs in a single card, 768 CUDA cores. Each GPU has 4 GB memory, so you have total 16 GB video RAM. You can put 2 of these are double wide cards, so you can put 2 of these in an R720. AMD FirePro S7000, it's a single wide, good old GPU, no NVIDIA magic over here. 1280 cores, you have 4 GB per GPU, so you can put 3, so totally you can get 12 GB in an R720 server. The Grid K2 and AMD FirePro S9000s are very high-end. If you have a lot of designer workloads, then like AutoCAD, SolidWorks if you want to run, or some games, these are pretty good. They have 2 GB, Grid K2, similar design as K1. They have 2 GPUs on a single chip, 3072 cores, 4 GB per GPU, so you have 8 GB total. And you can put 2 in a R720. AMD FirePro, 1 GPU, 1792 cores, 6 GB per card, so you can put 2, so you can get 12 GPUs. We categorize this workload as premium graphics. I'll walk you through what does the premium workload look like and the DX-heavy graphics for these cards. We have validated premium graphics workload, and we were able to get 32 users per S7000. And so we are thinking we can get 100 shared desktops. And I'll show the results in the next few slides. So another thing you want to configure, make sure when you're configuring GPU is take into account what Microsoft has recommended. This is a table Microsoft has published as part of their configuration for remote effects. If you're configuring remote effects, this the columns you see are the left, the resolution, the right are the number of monitors, and you have the VRAM that gets allocated on the video card. So let's take an example. If you want to deploy, say, a single monitor configuration with 16 by 12, we can support on a 4 GB card with a 16 by 1200 resolution, you can get 34 VMs. That is the minimum. That's the calculation Microsoft used to start each VM. It pre-allocates the memory on the video RAM. So it starts, it counts, and you can support 34 VMs. So you can use this table pretty much to calculate how many VMs you can support on the GPU card. One of the important things I want to call you out is this is only the startup RAM. This is not the runtime RAM. The runtime RAM can go up to 360 MB of RAM or 368 MB of RAM on a video card. So once the users log in, depending upon the application load, the DirectX manages the number of memory required for the application and over allocates if needed. So this is just a minimum RAM to start up the VM, and then there's a runtime RAM. Depending upon your application configuration, it gets configured once the user logs on, and depending upon the application load. So keep that in mind when you're configuring GPUs. So we talked a lot about the software architecture, our hardware. Now I want to walk you through quickly what is our workload design, how did we design it, what are some of the characterization. So what does our workload design look like? First one is we do is design the workload. We closely monitor the workload and design it based on real-world workloads, based on your task, knowledge, worker profile, power user, whether it's a graphic user. We optimize the Windows image, whether it's Windows 7 or Windows 8, with antivirus. We run all the optimization scripts that's required to run on a virtualization environment. Second thing we use is once we create the workload, we put the workload under test. And what we do is we measure the compute layer performance, CPU, memory, GPU utilization. We measure the management level performance of the connection broker, SQL server, how it scales. We monitor closely the IO bottlenecks. How does the bottleneck look like when 1,000 users are logging at the same time, when 50 users are logging at the same time, login storms and boot storms. Impacts of endpoints if you're coming from a mobile environment or if you're coming from a fat PC, how does your server scalability go up or down? And finally, end user experience. How long does a user take to log in if you're coming from a LAN or WAN? How does a network configuration impact the end user experience? And finally, we put the workload to test, we understand the performance characteristics, and then we build an end-to-end solution, give a scalability number, design guidance, and reference architecture. Depending upon the workload you chose, we'll give a scalability number, the hardware configuration, and design guidance, how to architect the solution, so that you don't need to do the heavy guesswork. So when you go purchase a hardware with the configuration, you can confidently say this can run 100 users. And we use LogInV as a tool to mimic most of the workloads, so you can buy those tools too and run it and see how you get it. So this is the list of workload. I'll walk you through from top to bottom. Basic is a very, very light workload, kind of a task worker profile. They run IE and Outlook for like 45 minutes in a time cycle. We allocate a 1 vCPU and 1 GB memory. Standard is a typical knowledge worker profile. They're running a couple of Office applications along with Outlook and multimedia, some multimedia. We allocate a little bit of increased RAM. And premium is one, we say a lot of applications running parallelly with Flash, graphics, as well as Office application. So we have increased the memory to 2.5. We thought like 1 vCPU is still good for the premium user. We have seen cases where people go for 2 vCPUs depending upon their workload profile. So all these three applications profiles are good, runs great with CPU, right? But as we go down the chain, premium plus graphics. What we did for the premium plus graphics is we took the premium workload added HD, high definition video, Flash, and HTML5 graphics video that plays at 30 frames per second and included in the workload. This will heavily tax the GPU. You can see how the GPU performs. And our success criteria is the output frames per second. When these contents are playing, you get a 30 frames per second output. Our recommendation for the video RAM are these applications used 80 to 125 MB of video RAM on the card. And we started with NVIDIA K1 and AMD S7000s. The next level is the 3D DirectX heavy. If you have a lot of designer workloads, SolidWorks, or any other stuff. We tested eDrawings, AutoCAD 2014. We have seen problems with 2012, 2011 because they are not remote effects aware. But we have seen a lot of support from our providers, AutoCAD and SolidWorks, more working with remote effects. And finally, we have also worked closely with Microsoft to design a Visual Studio workload that generates a kind of a modeling Google Earth kind of stuff, or Microsoft Earth in this case, that rotates the Earth in a 30 frames per second, and then the HTML5 video, and then HD. The first three applications, we thought, like when we interviewed a lot of designers, what they said was they don't really look for the frames. What they look for is the clarity, right? The resolution. They want to make sure that first the app works, and the second thing is the resolution they set, it works. So we found out that 16 to 24 frames per second is good enough as a user experience. And anybody playing like video or some rotating objects, 30 frames per second is our success criteria. Here you can see we have tested up to 384 MB of video RAM for this configuration. So it's taxing the GPU heavily. We have used the high-end cards, NVIDIA K2 and AMD S7000 when we tested this. So once we put the workload under test, this is the tools we use to measure the end-user performance. This is a very important slide. We use a tool called Liquidware Stratosphere UX, right? What it does is it measures the CPU, memory, disk, CPU queue depth, how long a user takes to log in, how long an app takes to load, right? It accounts for network latency. Across all the sessions the user has logged into. Gives a score between poor, fair, and good. Want to make sure we always get the good score. Along with it, we heavily use the Microsoft Performance Monitor tool to monitor graphics. These are the 5 parameters Microsoft recommends when you're running graphics workload to successfully measure graphics. One is your input and output frames. Frame skip for client resources, server resources, and network resources. What that depicts is if you are running out of client horsepower, or if you are having a network problem, or if you're having a server problem, this parameter will spike, so you know that your end-user experience quality is going down. Along with it, we used a tool called GPU Utilization, GPU-Z, and Process Explorer to measure the GPU utilization and the VRAM, how much VRAM is calculated on the GPU. So we talked about the workload, we talked about the tools. Let's see how it performed. The first one is the 150 user basic user test, Win7 RDVH on the R720 configuration, 192 GB memory, dual socket, 10 into 300 GB hard drives for the VMs, 2 for the OS, running Windows Server 2012 Hyper-V, right? Maximum CPU utilization, we were able to get 150 users. CPU utilization was 82%, memory was only 61. Network utilization 18 Mbps, so it comes to 200 to 250 kbps per user. Steady state IOPS was 1500. Average login time per user was 20 seconds, and the end user experience was good. Let's look at how the CPU performed. So the first 30 minutes is what the users are slowly logging. Every user is logging every 15 to 20 seconds. You see the CPU gradually going up from 20% to roughly around, I would say, 60%. And then once all the users are running in, they are running all the workload for a period of, like, say, 20 minutes, and they are logging off. During the steady state, we see CPU around 82%. That's what you see. The storage, how does the storage look like? During login, you see all the users are logging in, so storage spikes all the way to 3,500 IOPS, right? And it's mostly read IOPS, 80% is read. Out of 3,500, you can say 2,500 are read and 1,000 are write IOPS. And then once the user's logging in and then they're running the workload, the IOPS kind of stabilizes around 1,500, right? In this case, there's more write IOPS and read IOPS. Read is only 20% and write is 80%. And then users log off. Exact same workload we tested in an RD-SH scenario, right? The CPU almost looks same, but look at the IOPS curve. The IOPS is fairly nothing. Where we saw in the previous slide, it was 3,500 over here. The RD-SH, Same workload, we're able to get only like maybe peak around 500, and it's kind of stabilized around 140 IOPS. So if you have a choice whether you want, when you're deploying VDI, if you want to say whether I want to deploy RDSH or RDBH, if your apps are compatible, you don't have a lot of app compatibility issues, maybe RDSH is the answer for you. But if you want to go VDI, then you can deploy VDI for the users who they want. But this is again a design choice. We have published all the results, but this is again a design choice you can use as a guidance. So next one is the premium plus graphics, right? So this is running Office workload, HD video, Flash, and HTML5 at 30 frames per second. It uses 2 into S7000 GPU cards, 100 GB of memory, same hard disk, same configuration. We were able to get 30 users per GPU. We tested this configuration for 60 users, and the CPU was roughly 45%. We'll be testing for along with 3 GPUs, so we believe we can get 100 users. Output frames per second, we're looking at 30 frames. GPU was 88% utilized across 85 to 88% across 2 GPUs. Network bandwidth, this is in a very unoptimized LAN scenario, so the network bandwidth was 2 to 3 Mbps per user, but there's a lot of group policies you can tweak in RDS to balance the bandwidth and the quality. So you can see the GPU, this is the graph. I mean, this graph is very small, so I'll show you a bigger version of this graph. If it goes through, okay. Okay. So this is the output frames per second from the performance monitor. As you guys can see, the red one is the input frames per second. It's whenever a video is playing, it's throttling between 50 to 60 frames per second. The output frames per second is around constant across 30 frames per second. The reason why the output frames per second is 30 is because Microsoft caps the output from frames per second to 30, irrespective of how much our input frames is playing. Even if the input frames per second is 90 or 100, the output is going maximum you're going to get only is 30 using remote effects. This is the GPU graph, right? You can see GPU 6 GB across 2 or 8 GB. So you can say 5.6 GB is kind of utilized. This is the GPU Z results. 3.5 GB across one GPU and 3.5 GB across second GPU. CPU kind of looks constant, right? It's kind of throttling between 55 to 50%. The next one is the high-end DirectX heavy graphics workload we tested. This we work closely with Microsoft to design this workload. What this workload does is first compiles a 3D object using Visual Studio. This is the Microsoft Earth object that rotates at 30 frames per second. We compared with GPU and without GPU. So one of the things Microsoft has done is all of these graphical applications, it can run with GPU, or you can put more horsepower and render it on a CPU. It'll work on both. It just CPU requires more horsepower. You can see with the GPU, with the S9000s, we are able to get 65 users. CPU was only 50%. We're able to get 30 frames per second again. Memory was fully utilized. This card has 6 GB memory, so it was 5.6 GB. Same exact workload, we removed the GPU, ran it with CPU. CPU was already 80%, and you see the frames per second kind of dropped to 18. This proves that your end user, you're losing some end user experience quality, right, without the GPU. So again, it's design choice. If you don't want to invest in GPUs, if your users are happy with the end user experience with CPU, that's fine too. This is a very, very complicated chart, but I'll try to explain my best. So just monitor the colors I'm showing. This is with GPU. GPU, when we ran the workload, it's 30 frames per second across the board, right? The top pink one is the jitter. Jitter is nothing but the delay between 2 frames, right? So whenever there's a jitter, you know that frame quality and frame user experience suffers. So whenever the frames per second, if you see over here at the bottom, whenever the frames per second kind of drops below like 25, 30, you can see a lot of jitter. You can see the pink lines, pink dots all over the place. That means your end user experience is kind of sacrificed. Same exact workload, again, we ran it with CPU. You see the red dots, it's around 18 frames per second averaging, right? But the other thing you'll see is the blue dots, right? You can see the jitter all over the place. That means when you're playing a video or anything like that, there will be a lot of stuttering, right? So again, this is one of the reasons we believe, like if you're playing like light-end workload, you're good with CPU, but as you're going through the high-end workloads, you want to make sure you have GPU in your environment. So this is the summary slide of all the scalability numbers, 10 user POCs, right? We tested with single T110 server. We're able to get 10 RDVH sessions. We can run RDSH too. Some people ask, why can't I just do RDSH and RDVH in the same machine, right? I want to do maybe 50 machines with RDVH, and I want to use the same machine to run some terminal services. You can do that too, right? You're able to get 130 RDSH sessions and 75 Win7 on the same machine. Base deployment part we saw, we used a separate management server and compute host. If we use separate compute host, we are able to get 260 RDSH, 150 Win7, 230 Win8. Scalable, I mean, you can scale this linearly. The management server scales up to 2,000 users. We are tested with Microsoft. 4 compute hosts if you're using Win7, 1040 RDSH. You can go with 3 compute hosts if you're using Win8. And graphics part, again, we believe we can get 100 Win8 GPU, 1 management, 1 compute. So what are some of key takeaways from our design and analysis? First one is optimize for best performance and best end user experience. Just because you have a high-end data center equipment doesn't mean that you're getting the best experience at the end user. Anybody deploying VDI, they are looking for the same experience as local. So you want to make sure your experience is good. Do account for endpoint and network performance, because if you have a crappy thin client, how much ever you have a horsepower on the data center, you're going to have a bad experience. Same with network. Account for LAN and WAN scenarios, because experience goes bad in a WAN when there is a lot of latency. Software GPU is good. When you use CPU, is good for 2D model, like low-end multimedia, not HD videos. But as you move up the chain to high-end graphics, you want to make sure you have GPU in your deployment. And finally, always test your graphics, because most of the apps are compatible, but Microsoft has a mirror driver inside the VM, so some apps may not work, right? So you want to make sure you always test your apps before you deploy for the GPU-based desktops. And finally, test for end-user experience, because end-user experience is a very key in any deployment, in a VDA scenario especially. So what are some other things we are doing with Microsoft? We are validating Windows 8. We are going to publish a reference architecture with Windows 8 with all the sizing information. You'll see it in next 30 days. We're validating Office 2013 along with Link. If you're planning on deploying Link 2013, Microsoft has an offline plugin. We'll publish results on those testing. We'll see some demo too. We'll publish results on all the graphics, how we validated it, what kind of cards, how much density you can get. We'll also put reference architecture based on cluster-in-a-box deployments. If you're interested, we'll do that. And that's pretty much the end of my slides now. Who's ready for demo?
So while he sets that up, I know that was a lot of slides, so thank you for sitting through it. One thing we wanted to show, I'm sure a lot of you are familiar with Microsoft Server 2012. You probably looked at VDI. We wanted to give some insight into how we design it, how we go through this, but also the end user experience. So we talked about crappy thin clients. We'll call them bad thin clients. The client you choose does have an impact on the end user experience. We've seen a lot of customers who deployed VDI, either repurposed the wrong PC or bought the wrong thin client, and the end user discovered very, very quickly it wasn't the right experience for them. So we'll kind of give you a demonstration of good and bad, and what is good and bad. Right? So end users expect video to look a certain way when you may not have video requirements, but you may have video requirements in the future. Right? You may not do Link today, but you may have Link in the future. So when you look at the clients that you're buying today, a lot of customers, they want their thin clients or their endpoint devices, they expect them with 3, 4, 5. We have customers that have decade-old thin clients, right? So when you buy it today, you want it to last as long as possible. So it's important to consider these different scenarios. Am I going to do HD video, full screen, in 2 or 3 years? Am I going to deploy Link? Are they going to want to do webcams in 2 or 3 years? So that when you buy the right device today, you don't have to throw it away in 2 years and start over again. So we'll kind of touch on those pieces.
Cool. So one thing I want to show before I jump on the end user experiences, this is the Windows Server 2012, and I've deployed RDS roles, right? And as we talked about, we have a connection broker. We have RD Web Access licensing server. You can deploy RD Gateway if you're deploying from WAN or outside. We have 2 hosts, right? Virtualization hosts running pooled and persistent desktops. And I have a terminal server based RDSH running on another session host. I have two machines I'm going to show you. The pool machine doesn't have any GPU. I'm going to play a video, and in a full screen, this is a 1080p video, and see how it performs.
So you kind of get an idea. Pardon our older trailer, but HD video, full screen, non-GPU optimized.
Yep.
We'll say GPU optimized, right? If an end user started playing this video, they'd be like, why is my video not synced? Why is it choppy and pixelated? I don't think anybody would want to sit there and watch a webcast or a video in this particular scenario, right? So when the users have this kind of requirement, what you end up with is a bad user experience.
So there are two ways to fix this problem, right? Some of the things is this, since it's a Windows video, we can offload it to client if you have a suitable fat client or with codecs, right? So I'll play the same video. In a Windows media player. And you can see it's much smoother. The reason why it's smoother is it's getting offloaded to the client. You can see like the way to find out is all of the content is getting offloaded to the client. So you don't need to have the horsepower on the data center. If you have a decent client with codecs, Windows Media codecs, it gets offloaded. The other choice for the same video you can do is you can just put a GPU on the hardware, right? So let's go see how it performs on a GPU machine.
So that will on a virtual machine with non-GPU enablement. So what we did, if you have a Dell Thin client or a PC where you can actually redirect it, it'll execute local. So just like your PC, the experience looks almost native.
So this is based on this has an NVIDIA GPU card, and this is running on the server side. Clarity, right? And one of the things I want to show you is, as the video is playing, if I can pull quickly the output frames per second. When the video is playing, it was constantly around 30. The green line is the output frames per second. It was around 30 frames per second. And let me see whether I can pull these tools for you. As you can see, GPU is already using like 518 MB of memory, right? This is a NVIDIA card, NVIDIA Core 4000, 580 MB of memory already using. So let me go back to the desktop.
You can't handle this alone.
So this is a high fidelity experience using GPU, right? I also want to show you, let me pause this for a second, put it on the side, go to the desktop. We are running a couple of 3D apps, SolidWorks, this is the eDrawings model. Remote Effects has done touchscreen enablement, right? So this monitor is a touchscreen, and I can do this, right? I'm using just my fingers, no mouse, right? I can do touchscreen, swipes, all those things. So it's Remote Effects is the first one, RDP8 is the first one that's enabled to do touchscreens. It will pass through all the gestures. If you have a touch-based monitors, tablet PCs, you can do this with RDP8 on Remote Effects-based clients. Touchscreen compatible, and it runs smooth again. You can do like animation, right? It's all running smooth. This is what designers look for, right? Clarity. They want to zoom in and zoom out, rotate. Remote Effects is perfectly acceptable for this experience. I have another model, right? So let's do all these things. So you can see video is playing, graphics are doing, the system is not even taxed. Right, let's go look at the GPU. You can see the GPU is around, like whenever it was playing, the memory was around 500 MB, right? And it's getting taxed. GPU. There's no jitter, nothing. It's playing smooth. So it's with GPU, same environment, you cannot even run without a GPU machine. CPU based, it's going to stutter. You cannot even play all this. So this is the GPU demo. I'll come back to this again, have one more demo to show, but I want to show you the link-based demo.
So a lot of our customers are looking, I mean, how many people in the room are looking at Link for deployment for their VoIP? So I see a couple hands in the room, maybe more in the future, but Link and VDI has always been a challenge, right? So the previous versions didn't support a really good way to deliver Link to offload to the client. So the improvements in Server 2012, Link 2013, you can actually do Link with VDI, and we're providing sizing around this and how it affects your environment and how you would go deploy it. We'll kind of give you an idea of what it looks like.
Yep. The one thing I want you to guys concentrate is the left one. Microsoft has released a Link offline plugin. If you're deploying Link, what it does is, have anybody heard of harpening concept? So if you deploy Link in a VDI environment, what it does is all the webcam, all the traffic goes to the VDI server and then goes to the Link. That creates a lot of network traffic, a lot of CPU on the host side. So the right machine is configured on a VDI environment, no optimization plugin. The left one is a VDI optimized plugin you install on an endpoint. What it does is all the offloading gets, like the Windows Media Player thing we did, all the offloading of the Link takes place in the client side. That means nothing is going to the VDI session. Everything is connection between peer-to-peer. So we'll see a video called demo, right? Let me go and accept the call. It's towards the right. So want you guys to focus on the CPU graph on both the sides, right? Once I remove this one. The left one, you guys can see the CPU is hardly utilized, right? That's very minimal. On the right side, you can see CPU spiking very rigorously, right? This is one of the examples. If you're deploying Link, you need to throw a lot of horsepower, right, on the data center, or you can just install this plugin on the client and nothing goes to the data center at all. So this is the plugin. It is designed by Microsoft, free to download. If you have Link in your deployment, if you're considering deploying VoIP in the future, you may want to download this plugin and try it out. It works on Link 2013 today, and we want to show that to you. And we'll put reference architecture based on Link. We'll give you how we designed it, sizing guidance, and other stuff. You'll see it in our reference architecture. So I'm going to switch back to the GPU demo again. It's doing an echo. Let me close this models. Who likes playing games at work? So I have a good old game, Need for Speed. Let's see how it plays in a remote FX-based environment.
Hi, I'm Josie Marin, and I play Mia in Need for Speed Most
I
Wanted.
couldn't
Make sure
pause
you
this
do all
trailer,
your
but
racing
soon it'll
in
be
the
over.
game.
We'll go play the
On
game.
the streets, drive safely and responsibly, and wear your seatbelt.
I'm going to quickly reduce the volume a bit, just a tad bit. So the easy one, I'm not a game player. Withdrawal forward, auto.
So it's an example of one of the most, I guess, challenging scenarios you ever see with VDI is playing a full motion, full screen game. Games obviously look really bad if you're not delivering 30 frames a second. So remote effects offloading the GPU. It's still loud.
I'm not a good driver, so I crashed it, but. So anyway, this is, you see, I mean, you can try it out, right? This is running on a graphics card GPU-based machine. Again, graphics, this is an example, but you can see high-end apps, 30 frames per second. It'll play flawlessly on remote effects, so we want to show a demo. So that's our demo, end of demo. So now we can take any questions you have.
Any questions?
Come to the
We'll
mic.
be available at the booth if you guys would like to get our reference architecture, talk to us more about it, how we built it. We're happy to talk about those pieces. Go into more detail in the demos. We have some of the WISE clients down there as well that we could show you with it. Any questions? If not, you can catch us at the end of the room if you'd like. Okay.
All right, thank you.
We appreciate it. Thank you very much.